Hello, I'm Zhongjun from Alibaba Group. Today I will demonstrate AmbiSQL, a system designed for interactive ambiguity detection and resolution for text-to-SQL. As large language models become more prevalent in database query interfaces, accurately interpreting user intent remains a critical challenge. Let's look at how a classic text-to-SQL system handles an ambiguous question. Consider this query example. How many drivers born after the end of the Vietnam War have been ranked 2? This creates several conflicts. Firstly, does ranked 2 refer to the position column in the driver standings table or the rank column in the results table? Secondly, when determining the end of the Vietnam War, which date should be used? March, April, or December of 1975? Current systems simply choose the SQL candidate with the maximum probability. However, this statistical guess often cannot faithfully reflect the user's actual query intent. To address this, we developed AmbiSQL. It is built on a fine-grained taxonomy that covers ambiguity sourced from both the database elements and the large language model reasoning. The system operates using a two-stage pipeline containing ambiguity detection and iterative refinement. In the first stage, the system detects ambiguous phrases within the query, categorizes them, and formulates a specific multiple-choice clarification question. Then in the second stage, the system iteratively refines the original query by integrating user clarifications through multi-round dialogue until no new ambiguities are introduced during the interaction. In our demonstration, conference participants can explore AmbiSQL in two ways. Firstly, we provide a dataset of 40 ambiguous queries collected from the BERT and TAG benchmarks, covering 5 real-world databases. Additionally, users can also freely customize their own queries and databases to test the system's flexibility. Next, we will walk you through the user interface and the interactive workflow and show how AmbiSQL detects ambiguities and resolves them through human-in-loop clarification. As we can see, AmbiSQL's user interface is composed of 3 functional panels, which support query configuration, ambiguity resolution, and SQL generation with comparison, respectively. After the user submits a query, AmbiSQL detects potential ambiguities based on a built-in taxonomy using in-context learning and generates a clarification question for each identified ambiguity. These clarification questions are presented as multiple-choice questions in the middle panel. Each question always includes an abstain option and others option. After selecting the appropriate option, we add an additional constraint specifying that the drivers must be German and then submit our choices. At this point, another ambiguity is detected within the newly added constraint. We again select the correct option and submit it. After 2 rounds of interaction, AmbiSQL rewrites the original query into an unambiguous version and forwards it to the text-to-SQL backend. As shown in the right panel, the SQL generated by SQL with and without AmbiSQL is displayed side by side. After clicking the Compare Results button, the structure and the database level differences between the 2 SQL queries are highlighted. In this case, AmbiSQL successfully helps user clarify all ambiguities in the original query. Let us explore another case. We select a query example collected from TAG bench and run AmbiSQL again. For this query, 3 ambiguities are detected. First 2 of them are about how to formulate word clouds in SQL, and the last one is about exchange rate. We select options for the first 2 questions and specify the exchange rate to 22.5 and submit our choice. After SQL generation, we can also see the SQL generated by SQL with AmbiSQL applied the correct exchange rate, and the one without AmbiSQL didn't recognize the requirement of exchange between ZAC currency and US dollar. Thanks for your listening.